Module 2 dealt exclusively with the hardware aspects of local area networks. We talked about topology, which is how the workstations are actually hooked up to the medium, and we talked about the actual different types of media that can be used in local area networks. And we also talked about how each node on a network gains access to the medium, and that was those protocols were called media access control protocols. Well, Module 3 is going to deal exclusively with the software aspects of local area networks. So let's go over briefly what we expect to cover in Module 3. Module 3 is titled LAN Software, and in this module we will cover the LAN system software, and we will also cover LAN workstation software. And we'll talk specifically about software that we're going to find on a server, and then we'll move into more of an applications-oriented direction for software that we find on local area networks. And the first one will be database software, and then workgroup software, and we'll have definitions for each one of these. And then we're going to end Module 3 talking about software standards and protection. So to begin with, let's talk about the three main software types. The first type is application software, and application software is designed to solve problems. This is what we go to the store if we have a standalone system, buy software in order to solve a problem. Now, when we talk about application software, we usually mean that the software is going to run on the workstation and not on the server. Okay? The next type of software is workstation system software. And this software includes the operating system. We're going to define operating systems for you in just a minute. But it includes the operating system software and software for interfacing with the local area network. And then finally, we're going to direct our attention to server system software. This software also includes the operating system and the software for interfacing with the LAN, but the software that we find on a server has responsibilities and duties that are significantly different from what we might find on a workstation. So let's do a brief tutorial on an operating system. Let's talk about general operating system background. What is an operating system? Well, operating systems are software programs that manage the components of a computer. By components, I mean hard disk drives, floppy drives, printers, communications ports, which can be both serial and parallel, and just about any other type of peripheral you might find with a computer, and not necessarily external to it, but also internal to it. Let's look at some of the functions of operating system software. The first one, and a very important one, is the apportionment of main memory. Remember, main memory is random access memory, and we buy computers with 4 megabytes, 8 megabytes, 16 megabytes, whatever our requirements deem necessary, and it's the function of the operating system to decide how that memory is split up between operating system software, applications, and other types of software, primarily called TSRs, which you might recall. I believe I mentioned TSR stands for Terminal and Stay Resident. It's just software programs that are running in the background waiting for certain things to happen. The next function of an operating system is multitasking. Multitasking is an extremely important characteristic of an operating system, and we'll find it on both workstations and servers. But in essence, multitasking is the ability to handle multiple programs at once. And I'm going to talk about multitasking in detail in just a few minutes. Incidentally, I might use another term for multitasking. It's also called multi-threading. Okay, so don't let that confuse you. The third function of an operating system includes controlling the flow of data and code into the CPU. Now, the brains of a computer are in the CPU. And remember, a CPU stands for Central Processing Unit. And an example of a CPU would be one of the various Pentium models from Intel, or the 386 or 486. Those would be examples of CPUs. And it is the CPU that actually reads in an instruction from memory and executes that instruction. Now, some instructions require data before they can be executed, and so it's also the responsibility of the operating system to read in that data, read the data into the CPU and into just main memory in general, so that the instruction that's about to be executed by the CPU has the necessary data for completing the instruction. The next function, file opening and closing. Okay, practically everything on a computer is stored in files, or what's commonly called files. And the operating system is responsible for facilitating the use of files to read and write data into these files. If we had to worry about the specifics of reading and writing to files, I don't think that computers would be quite as much fun to use. The next function is the data reading and writing. So I just mentioned files. What we're talking about here is actually reading the data from the files, or writing the data to the files. The previous one just dealt with opening and closing the files. Next, we have transferring data to printers, modems, and other hardware. These other hardware, the other hardware I'm talking about here, are usually connected to either a serial port or a parallel port, or you could also have a bus plug-in card that has a connection to it. But in a nutshell, the operating system, once you have a command that directs the operating system to print, for example, it's that operating system that is responsible for moving the data from memory or the hard drive to that peripheral device to accomplish printing, for example. Or in the case of a modem, it moves the data that you want to transmit out to the serial or parallel port, and then the modem takes care of it from there on. The final function of an operating system that I want to talk about is it manages file hierarchy. Now, if you're not familiar with how most computers are used, let me explain a little bit. The file system has a specific structure associated with it, and that structure uses a term called a directory. And it's a directory that contains either other directories or it contains files. So if you think of the file system in a computer as starting at the top, which would be called the root directory, inside the root directory you have various other directories. They can be called anything you'd like to call them. You can also have just typical files inside the root directory. But then if you want to store files, for example, under your US West or Neat program directory, then you could create a directory with that name and then put all files associated with that topic down into that directory. And it's the operating system that actually manages the use of this file system. So in general, operating systems simplify the use of computers by removing the low-level details from the individual user. I mentioned before that if the users were actually responsible for managing the details of writing to the serial port, for example, I can pretty much guarantee you that computers would not be taking hold in households like they are today. So I've covered general operating system backgrounds. Let's see if you recognize some of the operating system examples. The first one is DOS. DOS stands for Disk Operating System, and this is typically what you find on PCs, although nowadays they're going more towards the Windows 95. The next one is Unix, which doesn't really stand for anything, I don't believe. It was just named by, I think, some programmers in California or Bell Laboratories. You typically find Unix operating systems on Sun Spark stations or some IBM workstations. And frequently there's been a big push lately to find Unix on PCs. One form of Unix is called Linux, and another one is called SCO Unix, SCO Unix. And I'm sure there's probably several others that are popping up now too. Probably the one you've heard of most frequently, though, is Windows 95. After Microsoft spent all that money to market that before it came out, I'm sure it's a household name by now. There's Sun OS, which you're going to find on Spark stations from Sun Microsystems, and another, I guess, the next generation of operating system for Spark stations is something called Solaris. So there you have a few examples of vendor software, vendor operating systems. Now let's talk in a little more detail about LAN system software. Generically speaking, the LAN system software is an extension of the operating system. Basically, it provides additional functionality to facilitate the use of the local area network. Now, the local area network you can think of as just being a peripheral device, much like a printer or an external disk drive or a modem. And the computer has to have some way of knowing how to access that peripheral, in this case the local area network. And it's the LAN system software that facilitates the communication then between the computer and the network. The primary function of LAN system software is to carry out LAN hardware-related tasks. Okay, what this means is interfacing to the medium, okay, actually putting data from your computer memory onto the LAN media. It facilitates input and output of data. So, for example, if we talk about a print job, it's going to handle that print job. If it's local, it's going to send it to a local printer. And if it's remote, it's going to put it out on the local area network, and it'll be transmitted to a remote printer server to be printed on a remote printer. And finally then, it directs other types of jobs too, or other types of requests. I'm not sure if I've mentioned the concept of client-server, but essentially a workstation is considered a client, and the clients are going to have requests. And it's those requests that are transmitted over the network to remote servers that are handled by the LAN system software. Now, the next point about LAN system software is that it insulates applications from the hardware details. In other words, the applications can make requests to remote devices without knowing any of the specific details of those remote devices. Okay? As an example, a workstation on the network might want to request data from a remote disk drive. And the user, remember, we have this transparency issue, which is a characteristic of local area network. The user doesn't care where that data is located. In fact, he or she doesn't want to do anything different if the data happens to be on a remote disk drive. So it's the LAN system software that makes all those details transparent to the user. So in the case of a read from a disk drive, the application makes the usual request, and the LAN system software then takes that request, issues a request over the network, and facilitates the whole use of a remote disk drive and makes it entirely transparent to the workstation user. Okay, another point about LAN system software is that we actually have system software associated with the LAN we'll find on both workstations and servers. So to illustrate what we might find and the various logical components that we find in LAN system software, let me point out that we'll point out what we have in workstations, and then we'll talk about what we have in servers. What I've shown here is we have an application running in the workstation, and this is what you might find also on a standalone system. So the unshaded circles here are basically unique to both you'll find in both standalone and those workstations that are connected to local area networks. So you have an application program and you have an operating system. And that operating system, you recall, facilitates the use of external devices. So we have here a disk drive, and it's the responsibility of the operating system to interface with that disk drive. Now, what do we add in a workstation? Well, we add LAN system software. And in a workstation, that includes something called a network redirector and a medium interface software. So these are, you can consider these as being logical blocks, even though they are contained in the same software package. Okay, now let's talk about the server. What we find on the server, in general, if we had a standalone computer, again, we would have an operating system. And again, its responsibilities would be interfacing with an external disk drive. Well, on a server now, we have something called server system software. And just like the workstation side, we still have some medium interface software. So the function of medium interface software is to facilitate the interface to the LAN medium. Okay? And it's the server system software that's going to handle interfaces between the server operating system and the medium interface software. Okay, let's look at an example now of what a local area network is going to look like with several peripheral devices. Now recall, the characteristic of a network is transparent access to local and remote devices. That is, a workstation or somebody who's working at a workstation wants to print, and he doesn't really care where he prints. He just wants to have access to a printer. Well, let me give you a few details on this diagram. Let's focus on this workstation down here. Now, there's nothing in any local area network literature or rules that say a workstation cannot still have its own dedicated printer. So that's what I'm showing here. But this dedicated printer maybe is not a real high quality printer. Maybe it's used to print rough drafts or something like that. Similarly, a workstation can also have its own local disk drive, and it can be dedicated to the one workstation. Now, if the workstation is connected up to the local area network, what you usually find on a local area network is something called a server. Now, I'm showing this server is acting as both a file server because it has an external disk, and it also is acting as a printer server. It's facilitating the use of a remote printer. Okay, so the hardware, which is the LAN media and the physical connections between the computers and the external devices, the hardware forms the physical connection, and the software, in fact, the little circles that we saw in the previous figure, form what's called the logical connection. It's the software that sends the data to the correct location. So as an example, the user at this workstation, if he wants to print on a high-quality printer, for example, then this workstation software looks at, or has been set up to say, parallel port 2 actually is a remote printer. And so it's the software internal to the workstation that whenever there's a print request to parallel port 2, it grabs that request, and the data, puts that onto the local area network, sends it over to the file server. So printer LPT2, which stands for parallel port 2, is actually a remote printer as far as this workstation is concerned, but he prints to LPT, or the parallel port 2, just like he prints to the parallel port number 1. Okay, that's why we call it transparent use. Now, how about disk drives and accesses to disk drives? We have our dedicated drive C shown here, which is local to the workstation. And the user here can access drive C just in any normal fashion, whether he's reading or writing or whatever. But in fact, he may have some data that's stored over on what's called F and G drives. So to this workstation, drive F is actually a remote disk, and as well as drive G. So once again, the system software that resides in the workstation has been programmed to know that if there is a request to access data on drive F, that request has to be packaged up, sent over the network to the file server, who then takes that request and accesses the remote disk drive, grabs the data that's been requested, and sends that data back over the network to the workstation that made the request initially. Okay, so that in a nutshell are the different functions of the network operating systems that are required on both the workstation and the local and the servers. So both of those are required. So now that we've had an introduction to operating systems and local area network system software, let's go into a little more detail now about what we're going to find in system software. So let's talk about system software functions. And the first function is that the LAN system software examines all application requests. So in my previous figure, I used two examples. I used a printer request and I used a disk access request. Well, it's those two requests that the software module called a redirector that resides on the workstation actually grabs those requests and sends those requests out on the local area network. So that little redirector circle that we showed two diagrams back, the sole purpose of that redirector is to examine all requests from applications and make a determination about where that request actually gets transmitted. Now, we have two types of requests then. We have requests that go to local devices, and we have requests that go to remote devices. So local requests then get passed to the regular operating system that's residing on the workstation. Okay, the local workstation, or the workstation's regular operating system, knows only about hardware that is attached locally. It doesn't know anything about remotely attached hardware. So if the printer is attached to port 1 of our computer, and that's where the application wants to print it, then actually the redirector will intercept that request and send it to the local printer. Let me go to the overhead again here, where I want to go over that in just a little more detail. We're focusing on the workstation here, so let me zoom in on the workstation. We have an application that's running on the computer or on the workstation, and every application request now, instead of going directly to the operating system, goes to part of the LAN system software called the network redirector. It is the function of the redirector to make a determination as to where the request needs to go in order to get handled. If it's a local, or if it's a local request, then that request gets sent to the operating system, and then it's the operating system that satisfies that request. Now, back here at the redirector, if the request requires the use of a remote facility, then it packages up the request, sends it to the medium interface software, and it's the medium interface software then that sends it over the network to the server. Okay, so that's what happens to local requests and, in fact, remote requests. So in our example here, we'll go through that one more time with a remote request. If we want to print, for example, our network redirector intercepts all requests from the application program. So in this case now, the network redirector will redirect that request over the network to our server, which would likely have a printer attached to it, and the print job then gets handled correctly. Okay, that's basically in a nutshell what happens on the workstation side. So now let's turn to the server side to find out what some of the specific functions of LAN system software are for a server. Well, servers receive multiple requests simultaneously. And in order to handle all of the requests have to be queued. Okay? And then we have this issue of multitasking or multi-threading come into play. So let me go to my overhead and show you a diagram to help me with this discussion. We're on the server side now, and the server only has two main logical software modules. The first one is the regular operating system, and the second one is system software that again facilitates the use of the local area network. So as a request is made from the workstation now, it's going to come over the LAN medium to the network interface card, and then it's going to come up into the server. Now we have usually only a couple of servers, and those couple of servers have to service requests from all workstations that reside on the local area network. So what happens is the server has a queue, and all of these applications, or all of these requests, pardon me, get stored in the server queue. So the LAN system software pulls the request off of the queue and sends that to the server operating system. And then it's the server operating system that is responsible for facilitating the interface to whether it's a disk or a printer. In the first case here, a database read, it's going to go to a local or to a disk that's attached to the server. If it's a printer, if it's a print request, then evidently this type of a server is also a printer server, and it's going to send that request onto something called a spooler that we're going to talk about in a little bit. Now, for this first example here, a database read, we're going to see that what's going to happen here is that the operating system is going to go to the cache, and it's going to see if this database read is actually located in the cache. And hopefully you remember what the cache is, because we covered that in Module 2. If the operating system does not find it in the cache, then it has to do a physical read from the hard disk. Okay, so that basically tells us some of the functions of the server software that we find in all servers that are on local area networks. The next function I want to talk about is that there's only a few tasks that the server software is responsible for in terms of local area networking. And those tasks, or in essence, the server software is mainly going to change between the following duties. It's going to accept requests, and these are going to come from all of the workstations that are connected to the local area network. It's going to issue reads and writes to satisfy those requests. So that would be write requests to disks or printers, for example, or reads from the disk drive. Then what it's going to do after it issues the request, it's going to wait for the completion to occur, and so it's going to handle read-write completions. And then the only remaining task is for it to send those results back to whichever workstation happened to request it. So there's just 4 tasks there: accepting requests, issuing commands to satisfy the request, waiting for the completion of the request, and then whatever data resulted from the completion of the request gets sent back to the requesting workstation. So just 4 main functions for LAN system software that you find on a server. However, I've simplified it a great deal. So now let's talk real briefly about a client-server model. The way I'm describing this whole process actually is considered a client-server protocol. And in essence, client-server means that the workstations are the clients and the servers are the servers, and that's why they're called servers, in fact. So the clients make the request. They make a request to a file server, for example, and then the file server has to service that request. So That, in a nutshell, is what client-server computing is. And you'll hear that quite often if you talk with people about networking and functions of networking. So let's move on then to this concept of multitasking, or I also mentioned that it's sometimes called multi-threading. And to introduce this concept of multitasking, I would like to use a graphic here. I want to talk about the evolution of the modern restaurant. So what I'm going to do first is show you how restaurants used to operate. Okay, picture yourself going into a restaurant and you're sitting down at a table. And in this type of a restaurant, there's no multitasking. There's only single tasking or single threading. So in this example, the waiter's going to come up and he's going to wait, well, hopefully on you. You're going to hope after this story that you're going to be the first one at the restaurant. The waiter comes up and he waits on you. And you, of course, have to decide what you're going to order. So let's say he asks for drinks first. You order your drinks and he goes back, gets your drinks, and comes back. Now, because he's single tasking here, he sits here and he waits for you to make up your mind on what you want to eat for dinner. Well, once you decide, then he's going to take your order and then he's going to walk back and give that order to the cook. Now, because he's a single tasking waiter, the only thing he can do is wait for that meal to cook. So he stands there next to the cook. Now, let's talk for a minute about the cook. Let's say you ordered bacon and eggs for dinner. Well, the cook gets that order, and we also have a single tasking cook. So the cook puts the bacon down first, because bacon takes longer to cook than eggs, so he decides to go ahead and cook the bacon. Now, because he's single tasking, of course, he can't start on the eggs. He doesn't know enough to start on the eggs. So the bacon takes 5 minutes to cook, and once the bacon is finished, he puts the eggs on the oven or on the stove, whatever he uses to cook these things. And again, he's a single tasking cook, so he's waiting for the eggs to finish. So everybody's waiting now. In fact, all these other people that came in after you are also waiting. All right, this is a single tasking restaurant, so that's all they can do is wait. Well, finally the eggs get finished, and the cook puts the eggs and the bacon onto the plate, and then he gets started on the other person's meal, because he couldn't multitask, so whatever this other person ordered now is going to start getting cooked. And again, the waiter is just sitting there waiting next to the cook, waiting for your meal. Well, finally then the cook is finished cooking the meals, gives it to the waiter, and the waiter comes and brings it to you. And of course, your first response is that the eggs and bacon are cold now because they had to sit and wait while the other meal was cooked, the meal for this person here. So, in a nutshell then, what's happening here is that this waiter is only capable of handling one task at a time. Now these people are all sitting back here waiting, essentially waiting for their turn. So if this type of a restaurant wants to stay in business, they better have a waiter for each table, and they better have a cook that learns how to multitask. Okay? Now a multitasking restaurant, which is the way restaurants evolved, they evolved from single tasking to multitasking. Now what's going to happen is this waiter gives you the menus, and then he goes over to the other table, gives them the menu, and finally the third table here gives them a menu. Then he comes and gets your drinks, then the next table's drinks, and then the third table's drinks. And he can take all those orders back at once, do all the drinks at once, and then bring them all back at once. Okay, so he's able to multitask here. He's working on drink orders for each table simultaneously. Then he takes everybody's orders and takes those 3 tickets back to the cook. And the cook now is able to multitask because he got a degree now in multitask cooking. Okay, I know you've probably never heard of that, but it exists. So now he's able to put the eggs and the bacon in the oven or on the stove simultaneously. And concurrently with that then, he can also cook this particular person's order. So those two, he's intelligent enough to know when to put them on, and they all finish at the same time. And now your waiter can bring out both meals at once. Okay? So this restaurant now is going to succeed because everybody's got degrees in multitasking. All right? Well, that is essentially what multitasking is all about. Okay? I used an example that we experience every day. In fact, I can pretty much guarantee you that if we still had single-tasking restaurants, that we probably wouldn't go out to restaurants very often because we would be waiting so long in order to get our meals. Well, the operating system, what it tries to do is remember, it queues up all these requests, and if it's doing a database read, for example, it issues that read request, and then it knows it has to wait on the data, so it goes and looks at the next request on the queue. And in this case, maybe it's a print request. And the print now, the data has to be sent to another port that the printer is attached to. So while the data is being read from the disk, the operating system can multitask, go ahead and grab the next request and send the data to the printer. Okay, so now we have a print occurring concurrently with the disk read. And this is essentially the whole concept of multitasking or multi-threading. You might even hear of a term called concurrent processing. Well, those are all the same thing. It essentially means that the operating system is able to perform multiple functions simultaneously. Now let's break that down just a little bit more. When I say simultaneously, the CPU is basically just like our brain. Okay? Our brains can only think about one particular thing at a time. So even though we might be thinking about multiple things, we're really not. It's only handling one thing. The CPU can only be working on one thing at a time. But what it does is time shares between the applications that require the use of the CPU. So the application or the CPU will spend a few seconds, in fact it's fractions of a second, working on one application. Then the CPU takes all the data and the state of the CPU and writes that to memory, and then reads in another application that it happens to be multitasking on, performs a little bit of a function on that one, and then pushes that one out to memory for later use, and basically just revolves through all of the different tasks that require the use of the CPU. So this happens so rapidly, though, that to you it looks like things are running in parallel. But they're not actually running in parallel. The only way they can run in parallel is if you have two CPUs both operating in parallel in your computer, which do exist, by the way. So in essence, then, the CPU is so fast that it's able to give you the perception that it's handling multi-tasks all at the same time. All right, now we're going to talk about specifically workstation software. Okay, it seems like we're bouncing back and forth, but we're trying to start at a high-level view and zero in on some of the specifics. So LAN workstation software essentially can be divided into three main classes. Those three are application, workstation, system, and LAN system. So let's talk about application software first. Application software provides the logic to solve problems. And if the applications require the use of hardware devices, it's this software that actually makes the requests of the hardware devices. And again, those requests are handled by the operating system or the LAN system software. And finally, the applications actually make the requests to the software in order to accomplish that whole task that you bought your application software to do in the first place. All right, the next type of workstation software we're just calling the workstation system software. This is essentially the same as the operating system software for all practical purposes. So I have two types of system software. I have workstation system software, and then I have workstation LAN system software. So that second one there actually is the one that facilitates the use of the LAN. But now this the workstation system software, what does it do? Again, it facilitates the requests for services provided by devices that are connected locally. Okay? The workstation system software does not have any idea about a remotely connected file server that's on a local area network. Has no idea about it, doesn't even care about it. It only cares about local devices like disk drives, modems, floppy disk drives, that sort of thing. And also the operating system is going to handle more of the low-level details that are required in order to handle all of the requests to peripheral devices. The third type of workstation software, LAN system software, is what facilitates our requests to remote devices such as printers and disk drives and faxes. Remember all the different types of servers we could have? File servers, printer servers, fax servers, modem servers. Well, it's the LAN system software that we find on a workstation that facilitates the use of those remote devices. All right, if you recall our diagram, in fact, let me put it back up for us again. We have essentially three interfaces here. We have an interface between, actually it's, just three. We have a software interface between the application and the redirector. Let me zoom in for you here. So we have one interface between the application and the redirector. We have another interface between the redirector and the operating system. And then finally we have a third interface between the redirector and the network interface module. So you can see that the network redirector plays a huge role in LAN system software. So let's talk about now these software interfaces. And let's start with the application to redirector software interface. Whenever the application wants to have some service from our external devices, whether they're local or remote, the application issues something called an interrupt. There's different levels of interrupts on computers, but essentially an interrupt can be a hardware interrupt or it can be a software interrupt. And this is just a special utility that the CPU has that once it gets interrupted, it can jump to a completely different part of memory to execute code that's going to handle this, to handle the interrupt. Okay, so whenever an application requires the use of external services, external devices, it issues an interrupt to the operating system. Now, in the case of LAN system software, whenever LAN system software is installed on your workstation, the interrupt is actually intercepted by the redirector. Okay? The redirector then takes a look at this request that the application is asking for and decides where the request needs to go. Does it need to go to the local devices or does it need to go over the network to any of the servers? Okay. Now at this point the application doesn't care where it goes. In fact, the application doesn't even know that the redirector intercepted that interrupt and is looking at the request to make that determination. Now, because of these interrupts, I want to point out that not all applications will run using all types of LAN system software. And that's because the different systems have different interrupts and different interrupt levels. And your application may be trying to issue an interrupt that is not recognized by the LAN system software. So that's something that you want to be diligent about when you check if you're going to buy applications. Make sure you ask whether or not it will run under the specific LAN system software that you're using in your local area network. Let's move on now to the operating system and redirector interface. This is a pretty simple interface because essentially if the redirector determines that the local operating system or the operating system on the workstation can handle the device, then all it does is pass that request on to the operating system. So in essence, the redirector has just muddled things up by becoming a middleman. Okay? Under a normal situation, the application would have made that request directly to the operating system. But now it goes from the application over to a redirector, and then the redirector is just going to send it right over to the operating system. So that's actually the simplest of all of the interfaces. Now let's talk about the last one, and that would be the LAN redirector interface. This is actually a significantly more complicated interface because it requires the use of file servers or printer servers which expect to have the requests formatted in a certain way. So it is the responsibility of the interface between the LAN and the redirector to use something called APIs, or application program interfaces. And what an API essentially does is it takes the request, puts it in a format that the receiving end is going to understand, because the receiving end has to understand the request in order to service that request. So it uses an API, an application programming interface, to format the request in the right format for the receiving station or the receiving server to be able to act on. The next thing it does is it places data onto the network. All right, it takes it from our computer's memory and puts it right onto the local area network. And the reverse of that is that it receives data from the network. Okay, it's a full duplex link there usually. And finally, the function of that interface is to format message blocks for transmission. Okay, so if the message that you want to send is too long for the particular protocol, it'll break that up into blocks of various sizes in order to send those over to the file server or the other workstation that you're sending it to. Now, that was some specifics on workstation software. Let's talk about LAN server software. LAN server software is inherently more complex than workstation software, primarily because it must have this multi-threading or multitasking capability. One other reason why it's more complex is that it has to interface with usually a higher number of external peripheral devices, for example, printers, disk drives, modems, and faxes. The next aspect about LAN server software is that the software can be integrated with the OS into a single package. And what I mean by this is that whereas prior we had two different types of circles representing the system software and the LAN system software, and I hope this doesn't get confusing for you, but one option we have is that you can take your LAN system software and your server operating system software and integrate them together. Okay? So what does this do for us? The advantages of this are that you can optimize both sets of software for the local area network. In other words, the LAN system software is already optimized, but the server operating system software can now be optimized because it's a given then that this is going to be used on a local area network. Additionally, this operating system many times is just the same type of operating system that you'll find on a workstation. In this case now, the operating system can actually be custom tailored to be residing and used on the server. Well, how about some disadvantages of this configuration? The first one would be that usually this operating system has certain functions that are already available to it, and when you integrate the two into one package, you end up duplicating portions that already exist. So it's like reinventing the wheel, which usually costs money in the form of time. Another disadvantage is that the development effort to integrate the software components takes longer. Maintaining the integrated software components is also more complex, and troubleshooting is also more difficult because now you don't know if it's the LAN system software that's messing up or the server operating system software portion of the integrated package that's actually causing some problems. There's only one vendor that I know of that actually uses this method for integrating their LAN system software and their regular operating system software, and that would be Novell. Okay, the Novell NetWare product line actually integrates both the operating system and the LAN system software into one package. Okay, the other option, instead of integrating the two software modules, is to actually let me use the workstation figure in this case. But instead of combining the two, we're going to keep the operating system separate from the LAN system software. Okay, so what we would say is that the LAN system software can be written on top of the existing operating system software. Okay, some advantages of this particular scheme is that we can reuse the software, we can reuse the operating system software. We have a faster development because usually the operating system software is already completed, and all we have to deal with are the LAN aspects of the software. In this configuration, it's easier to maintain because you can always take off the LAN system software, just remove it, and determine if your problem still exists. So that means that troubleshooting is also easier when you do not combine the LAN system software with your usual operating system. The disadvantage of this, however, is that you have these separate components. For example, the redirector that's going to examine your requests, and then if the request is local, it sends it to the operating system. Okay, if this part didn't exist, then what would happen is the application would have just sent that request to the operating system directly. So this makes the operation of the software slower and less efficient. Some examples of this type would be Banyan Vines, which runs under the Unix operating system. And another one is Microsoft's LAN Manager or IBM's LAN Server. And both of those last two actually run under the OS2 operating systems. OS2, of course, is an IBM operating system. Okay, now we have talked in some detail about operating system software and LAN system software. Let's see some of the functions of operating system software. The first one is called Optimized I/O, which stands for input and output. The purpose of optimized I/O is to increase the performance of file accesses. Okay, we had two techniques for accessing files or accessing data. We had disk cache, okay, and we've discussed cache. Caching is primarily a hardware technique for improving or optimizing our input-output. We still have to have software to know enough to go to the cache to check it, but it's primarily a hardware solution for improving the speeds. There's a software one, though, that's called Disk Seek Enhancement that improves our accesses to our hard drive. Essentially, Disk Seek Enhancement, its purpose is to arrange the requests that are going out to the hard disk drive, arrange them in an order that will improve the efficiency with which we're accessing our hard drive. Okay, let me show you an example of this, and I'm sure then that it will help you understand. What I've tried to do here is draw a hard disk drive. Okay, so this would be our disk, and what this disk is going to do is it's going to spin. It spins around. Okay, and each of the dotted lines here represents a certain cylinder on the hard disk drive. Now, recall the three components of access time for a hard disk drive. We had the seek time, which involved moving the head to the proper cylinder. Then we had latency, which involved the time that it took the data to rotate underneath the head. And then we had the actual data transfer time, which is a physical time that's required to read the data from the disk and transfer that data over the bus to the main memory. Now in these diagrams, I'm saying that the little black box is my head that is going to actually do the reading of my disk. So in this case, I have 4 disk accesses that are requested. The first one starts out here, and then my next access moves in this case, just 1, 2, 3, 4, 5 cylinders, performs a read, and then the next request actually has to move back out 1, 2, 3 cylinders in order to find the data. And then finally the 4th request has to move in 1, 2, 3, 4, 5 cylinders to read the final request. Now, I've only shown about 8 or 10 cylinders in this, but disk drives literally have hundreds of or thousands of cylinders on the disk. So I've simplified this problem a great deal. So you can see now, if you were to monitor the action of the head on the disk drive, it starts out, goes in, goes back out, and then comes back in just to do 4 different reads. Disk-seek enhancement strives to arrange those read requests in an order to optimize the seek time of the disk drive. So we're not going to be able to do much with the data transfer time, because that's the amount of time it requires to transfer the data. And that's going to be a fixed amount unless we have a faster bus or something like that. What we can improve, though, is the seek time using disk-seek enhancement. And hence, that's where the name comes from. But in a nutshell now, we've arranged our read requests so that the head has to move in the shortest distance to make the first read, then it moves only slightly more to make the second read, then slightly further still to make the 4th, and then finally it reads the last one. So if you remember, in my disk, without disk-seek enhancement, I started in the 2nd cylinder, and then I have a read in the 4th, and then the 7th, and then in the 9th cylinder. But in this case, I went all over the map here to accomplish that. With disk-seek enhancement, I start at the 2nd, then go to the 4th, then go to the 7th, then go to the 9th. So it's a nice smooth movement for the disk head. Now, we can't do much about latency either, because the data could be residing anywhere on that particular cylinder, and it's still going to take a finite amount of time for that data to rotate underneath the head. So this is one category of optimized I/O, and it is one function of the LAN operating system. In fact, it's not necessarily restricted to LANs, but that's where you find it most of the time, because file servers have so many disk accesses that it has to have some optimized input and output in order to keep up with all of the requests. The next LAN OS function we're going to talk about is fault tolerance. And fault tolerance is defined as the ability to survive failures that ordinarily are disabling. A few examples of failures would be power failures, disk crashes, or even major user errors can cause an entire network to become disabled. Fault tolerance is such an important component of operating systems and networks in general that we're actually going to spend a period of time here talking about fault-tolerant methods. Okay? Fault tolerance, in a nutshell, involves having redundant hardware that will protect us from the types of crashes that are going to disable the network. In addition to hardware, though, it also requires having the software to use it. Now, by redundant, I mean extra or copies, much like you have to add redundancy in order to detect errors in any sort of communication scheme that you probably learned about in Data Communications and Protocols course, if you happen to have the last course. So let's move into fault-tolerant methods. The first method is a very simple one. Make backups of directories, FAT, which stands for File allocation table, and other files that are critical to the operation of accessing data on hard drives. It seems to be that hard drives are the most common component of a computer that fails. The next method, what we call read after write. In this method, we write to the disk and then we reread what was just written to the disk to make sure that it was written correctly. Now, if you recall a communication scheme called Echoplex that you might have covered in your data communications and protocols class, Echoplex was the protocol that said, whatever I send you, you're going to send back to me so that I can determine if you received it correctly. Okay, so that's all the read after write method for fault tolerance really is. The next method is called mirrored disks, and this method is actually best explained with the use of a graphic. But the fault tolerant method of mirrored disks essentially writes to two disks. So we have two controllers called duplex controllers that perform the same operation, and data is going to come across the bus and it's going to be written to file 1. File 1, for example, is going to be written to disk 2, and file 1 will also be written to disk 1. Okay, so these are mirrored disks. The reason they're called mirrored is because if you looked at one and looked at the other, or actually if one disk turned and looked at the other disk, it would be as though it were looking at itself in a mirror. What this requires, of course, is two controllers that are controlling each of the disks, and also the software to provide the right commands to each of those controllers. Now, there's an additional benefit to having mirrored disks, and that is that if disk 1 and disk 2 have the same type of information, that when the advantage is when a read occurs, let's say two reads enter a file server, the file server can issue one read to disk 1 and can issue the other read request to disk 2. So in this case, you essentially have two disk accesses going on in parallel. And that's a very important, a very beneficial thing to have going on. The next fault-tolerant method is called RAID. RAID stands for either redundant array of independent disks or redundant array of inexpensive disks, depends on who you ask. And essentially, RAID, the goal of RAID is to spread the data out over several disks. Now, let me use a diagram to explain this one too. Here we have our server, and attached to the server is some RAID disks. Now, it doesn't actually write the whole contents of file 1 to each of the disks. Okay? It writes part of file 1 to disk 1, part of file 2 to disk 2, part 3 of file 1 to disk 4, and then adds some parity for file 1. Now, recall what parity is in a communication scheme. Usually parity was a bit that we added. It was extra, that basically told us whether we had an even number of ones or an even number or an odd number of ones. And so that parity was considered redundant. So in this case, not only do we have redundant disks, but we also have redundant information being stored on one of the disks. And the whole idea behind RAID is if one of these disks happen to crash, the idea is that with part 2 and part 3 and the file 1 parity, we can actually generate part 1 of file 1. Okay, similarly, for another file, we have part 1 stored on disk 3, part 2 on disk 1, and part 3 on disk 2. And then we have the parity stored on disk 4. So obviously, if we lose the disk that has the parity, we still have all three parts to the file, so we can completely regenerate the file. And the whole idea then is if we lose any part, the other two parts plus the parity are going to allow us to completely reconstruct that file. Okay, the last fault-tolerant method that we will discuss is something called duplex servers. Essentially, duplex servers are two identical servers with mirrored disks. Okay? And really very critical in duplex servers is having the software with the ability to make the change. So if we go to the overhead, what we see here is we have one server on the right and we have another server on the left. And we have mirrored disks attached to both of the servers. So we have one server that is sending data to the disk controller and writing to both. And then the other server is also taking data using the other disk controller and again writing to both disks. So the whole idea here is that if one of the servers fail, then we still have another server that is up and running and is able to take over the responsibilities of the file server and accomplish all the same tasks that the users are going to require. So the bottom part of the figure here is basically just like our mirrored disks that we talked about a few minutes ago, and then we're adding two file servers that are performing the same functions. They have the same software, the same hardware connections. So incidentally, duplex servers represent the most expensive of all solutions to fault tolerance, mainly because we're providing essentially two systems. So in case one goes down, we have the other one. It's like owning two automobiles. In case one fails, you always have another one that you can hop in and drive to wherever you need to go. Now, Module 6 is going to talk about specific vendors' LAN operating system. The chapter in your book also has some information on some of these operating systems. So what I'd like to do right now is go over very briefly some specific LAN operating systems, and we're going to cover them in more detail in Module 6. So we'll only pick out the highlights here. The first one is Novell, and let me tell you a few of the Novell terminologies. There's a product called NetWare Lite, which is for peer-to-peer networks. Remember, peer-to-peer networks were those networks that didn't have a file server attached to the network. Okay, the individual workstations actually performed file server functions. Then there was NetWare 286, 386, and 4.0 for obviously the different generations of CPUs that are being provided by Intel. And these are for higher-end client types of networks. The Novell system provides a high degree of fault tolerance, and in fact, specifically it uses mirrored disk fault-tolerant methods in case one of the disk drives fails. And among other optimizations, the most prominent one that it uses is disk caching. So that is the Novell software. The next one is the IBM LAN server. And IBM LAN server runs on OS/2 from IBM. And in fact, the topology that it supports is token ring. Okay. The next one, Microsoft's LAN Manager, also runs on OS/2. And LAN Manager for Microsoft supports both token ring and 802.3. Okay, so what is 802.3? Hopefully you haven't forgotten it from Module 2, but 802.3 is the same as Ethernet, and that is using a bus topology with contention protocol, contention MAC protocol, or the carrier sense multiple access with collision detection. Finally, I said we would be brief about this, but and we are. The next one is Banyan Vines. This is a company called Banyan. This one runs under Unix. And the fact that it runs under Unix actually simplifies things a great deal because a lot of wide area network nodes use the Unix operating system because, again, wide area network nodes typically contain mini computers and mainframes, and it's those types of machines that commonly use the Unix operating system. In this case, these Banyan Vines can operate both as a workstation or a server. So we see that the software can actually reside on either one of those. One of the key identifying traits of Banyan Vines is something called street talk. And Street Talk is very similar to having a domain name server. And if you recall what a domain name server is it's a server that allows you to send it a name, for example, ames.edu, and the server actually looks up ames.edu and provides the exact network address for the location that you want to go to. So that's called Street Talk, and it's located on each server in the network. Okay, so that's a real advantage because all you're doing now is sending the name to the server, and the server has its own database and can look up the name and get the address. So that's a real benefit. It makes the lookup of that resource significantly more efficient. Okay, we just covered different operating systems from the different vendors. Previously, we talked about different types of hardware that we might encounter on the LAN network or on the local area network. And one of the key components of all these that I've been talking about is called interoperability. But since we're talking about software in this module, let's talk about interoperability of server software. For interoperability, all network components can use shared network devices. This is a requirement of interoperability. Anything that's located on the network, we ought to be able to access using any other type of operating system on the nodes. Next, on any local area network, we might have multiple file servers, and these servers have to operate compatibly in order to obtain full benefit of even having the local area network. Now, both of these requirements are very simple to accomplish in a homogeneous network. Okay, recall what a homogeneous network is. A homogeneous network is a network that uses all the same operating system and it uses all the same workstation types. It doesn't mix Apple and IBM or OS2 with Unix or anything like that. They're all the same, so that's homogeneous, and we can maintain interoperability much easier if we're on a homogeneous network. Now, interestingly enough, not all of these operating systems are interoperable. Now, if you were to go back and look at the details of the operating systems that I went over, you might think that if you pick two operating systems out that ran on top of the same operating system software. Let me rephrase that. I'm talking about if we went to pick two LAN system software vendors that use the same operating system software, that you would think that those two would interoperate. But in fact, if we looked at IBM's LAN server and LAN manager from Microsoft, these are two examples where those two operating systems don't interoperate on the same network. So that really creates a lot of problems for the LAN manager. Let's look at some other possible complications of having multiple or differing network operating systems. We'll look on the overhead here and just go through this table. Let me zoom in for you. Recall that one of the key differences of working on a local area network is the use of user IDs and passwords. And what sometimes you find is that when you use two different operating systems in a network, that sometimes those and the way they format user IDs and passwords are not compatible. The same can be said when talking about servers and trying to synchronize user identifiers and passwords. Now, a lot of times workstations will make essentially simultaneous requests to file servers, and having two different network operating systems reduces our ability to simultaneously access data onto servers. Even though that's a key requirement and should definitely be allowed, this is a possible problem of having more than one operating system on the network. Another problem is the ability to access data on one server and print to a spooler on another. This is essentially a broadening of the previous point where, in general, we're trying to make two requests to two different servers. One is involving data and the other is involving printing. but sometimes we end up with complications when we try to do that. Another possible complication is running applications that are obtained from both servers. So here we have two different servers again, and applications can be stored on either one. And when we try to run from both of those servers, sometimes we get some problems. Here's something on application program interfaces, or APIs. And it's very common to find that when two network operating systems are in the same network, that the APIs are not common, although they strive to make them common. Similarly, even though an OSI network and transport layer usually try to have the same type of peer-to-peer protocols, sometimes we end up having complications if two different operating systems are used. And finally then, having two redirector processes also leads to complications when we have more than one network operating system on servers in our local area network. Well, that pretty much is going to complete our discussion of operating systems, local area network system software, and the functions and some of the benefits and their responsibilities when associated with a local area network. So it's time now to move on to some other types of software that we're going to find on local area networks. One of the most important functions of a local area network is to provide printing capabilities. Now we have an entire chapter when we talk about LAN administration that's going to talk about printer spoolers, but it's worthwhile at this point to go ahead and talk about printer spoolers. Let me start with the diagram and briefly go over the function of a printer spooler. We have here a workstation up in the upper left, and then we have a printer server down in the lower left. And our modules here, I've left them blank to help you imagine what these circles were, but this was the application, and then we had some LAN system software here, and in this case now I'm combining the redirector and the media interface into one circle. So this circle here represents all of our LAN software. An application wants to write to a network printer. And this is sort of a review, but that request gets intercepted by the redirector, who realizes that the print request is to a remote printer, formats the message, and puts that out on the local area network. The data travels down the local area network to our printer spooler. Now, what's key to understanding the function of a printer spooler is to realize that a network printer cannot print multiple copies at once. In other words, a printer cannot multitask. All right? It has to be printing one document and one document only. So how does a user print if the network printer is busy? Okay? The user is able to print with the use of something called a spooler. A spooler allows logical printing to take place. So what actually happens is that print job that gets transmitted over the network is gathered up by the spooler. And that spooler essentially takes that print job and writes it to its memory, and then schedules that print job into what it can have as several queues. But a job will only get scheduled into one of the queues. So we have Q1, I'm showing here, with 2 print jobs waiting. Q2 has 4 print jobs waiting, and Q3 has 3 print jobs waiting. So as soon as the spooler sees that there's a print job, it writes it to disk. In fact, it writes it to a hard disk and then puts it in a queue. Then as soon as the network printer that the job is intended for, so for example, maybe Q1 is intended for our draft printer, and Q2 is intended for our laser printer or our final quality printer. You might realize then that the reason why we have more of a backup in Q2 is because this printing takes longer to get the high quality. Okay, so as soon as the draft printer is complete, it's going to look at the next job in the queue that corresponds to the draft printer, and it's going to go ahead and begin printing that job. Now, if another print request comes over the network, the spooler is going to take that print request and the information for the job, write it to memory, and put it in one of these queues. So based on that description, let's go ahead and formalize your notes and put up some information on printer spoolers. So just to reiterate then, printer spoolers can only print one job at a time, but it's going to receive requests simultaneously. Okay? This leads to the concept of logical versus physical prints. Physical prints are obviously where the printer server is literally printing the document. The data is being sent to the printer, and the printer is spitting out pages after they've printed to the page. Logical print, on the other hand, is when the user on a workstation wants to print, executes the print command, and sends the data to the printer server. Now, for all practical purposes, the workstation is freed up, and the user thinks it's being printed. Okay? When in reality, that print job has gone to the spooler and has been stored on a disk and has to be scheduled to be printed. So if the printer is free, then the printer spooler will immediately schedule the job, and it'll go ahead and get printed. So that's the main difference between logical and physical prints, and it's the printer spooler that allows the logical printing of documents. Okay? Because the spooler receives multiple requests simultaneously, the requests get stored in a queue. Okay, so the spooler queues the print job. It's the entire print request plus the entire file that's required for the print that gets stored on the printer spooler. And when the printer is free, the job is scheduled and the output finally arrives. The next aspect about spoolers is the order in which the printing actually occurs, and we have several different methods for deciding this. The first one is called a FIFO. That stands for first in, first out. This is what we're all used to when we enter the line at the bank. The first person that enters the line is going to be the first person that's served. So that's first in, first out. Another method is called smallest jobs first. Now imagine, if you will, that somebody has a huge document that they want to print. They send the request to the printer spooler, and that request, along with all the data, gets stored on disk. Simultaneous to that, but a little bit after that, a very small one-page print job is requested of the printer spooler. Again, the request and the information gets stored on the disk. Now, instead of a first in, first out protocol for transmitting or scheduling the print jobs, the smallest jobs first would examine all print jobs in the queue, determine their size, and take that smallest job and print that one first. The reason for this is because if we print a large job in front of a small job, then even a one-page print can take an hour if that large job requires an hour to print. So that's called smallest job first. And finally, we can have user priorities. So again, the requests are going to go into a queue, but before a job is actually scheduled, the priority of the user is examined, and any users that have higher priorities will be moved to the front of the queue. In fact, usually it's your super user or your LAN administrator who will have your highest priority. So whenever it prints a job, the printer spooler recognizes that user ID and puts his print job, schedules it right at the top of the queue. Let's look at some other spooler options. Spoolers are very complex software programs. Let me zoom in for you here. And they have many different options. And let me just quickly list these. Collect printed output. That's what one function of or an option we can set on a spooler. My previous diagram showed two different printers, a draft quality printer and then a final quality printer. So another option is directing print jobs to designated printers. Another option is after we've printed, maybe we don't want to remove that print job from the queue, but rather just leave it on the disk so that we can reschedule it if we want to. Another option is to just hold the jobs in the queue before we print them. For one reason or another, you may want to just keep the file in the queue for a certain period of time before printing it. Okay, an example is a software programmer who's looking at all the errors and warnings output from his compiler. Maybe he doesn't want to print all that, but just wants to hold it there for a while. Here's a common option is to view jobs on hold in the print queue. So this will give you an idea of what sort of jobs and their sizes that are currently in the queue. Set number of print copies. This is actually an important spooler option because let's say you have a big document and you want to have 10 copies made. Rather than issuing 10 print requests and sending the job over the network 10 times, you can send the job once and tell the spooler that you want 10 copies. So that significantly cuts down on the amount of traffic that goes over the network. We talked about setting print priorities. This is one that's commonly used, deleting jobs from a print queue. Maybe you want to print something out and you realize you made a mistake, so you don't want to waste 10 or 20 pages on a document. So you go into issue a spooler command and actually delete the job from the queue. Another option is just attaching and detaching printers from the print queue. We can also set priorities on jobs, so not only on users but also on jobs. A common function or responsibility of a LAN manager is to add or delete printers, start and stop the whole spooler process. Print banners. You might recall what banner pages are. Banner pages are those pages with some sort of heading or title on them that indicate that a new job has started. And so all the pages underneath that banner page or that come after that banner page is related to one print job. You can have banner pages show up at the beginning, at the end, or both. But printing banner pages can actually lead to a waste of paper if your print job only requires one page. Here's another option for print spoolers is closing jobs based on a timeout, because some applications like spreadsheet applications will send data to the printer and just leave the channel open without closing it. And usually the spoolers will not begin scheduling a print job until the job is actually closed. And then finally, statistical reports are important because what might show up in a statistical report, for example, is the average number of jobs in a queue. And another important one is the length of time that the queue actually, or that the job is actually waiting in the queue. What these are going to tell you is whether or not you need to attach another printer to the local area network. All right, let me give you another example that you can probably relate to. If you walk up to your bank teller line and there's only one teller working and there's 20 people in line, then the average number of people in line, if it averaged 20, that'd be a good indication that you need to have some more bank tellers up there. Along those same lines, if you happen to wait 10 minutes, that also might be an indicator that you need more tellers to handle the volume of customers coming into the bank. Well, that's going to be all I'm going to say on printer spoolers, because we're going to cover printer spoolers and in fact some of these other topics in later chapters. So let me briefly move on then to backup software, and we're going to cover backup software in one of the future chapters also. Backup software, the responsibility of it is to write files to a backup device, and it also is responsible for reading files during a restoration procedure. One key component or characteristic of backup software is called compression, and it's another responsibility to enable compression in order to obtain higher disk capacity. When your data is compressed, you can fit more of that data onto the disk drive, And in fact, though, this type of compression has to be what's called lossless compression, where you can exactly reconstruct the original file, because in this case, if you start losing characters or bytes or something like that because the compression algorithm is lossy, then that is not conducive to the type of environment that we have in a local area network, where we want to have the files exactly reconstructed. Again, we'll have an entire chapter, in fact, on backup and recovery techniques in Module 4. The next one is utility and administration. Here again, we're going to have an entire chapter on utility and administration, so I'm going to leave that one alone, and we'll get into that in Module 4. Well, the whole idea behind having a local area network is sharing peripherals, for one thing, sharing peripheral devices, sharing files, basically sharing anything that anybody might use on a local area network. So we have this concept of shared usage, and there's specific requirements associated with shared usage. Recall that we didn't have this problem when we talked about standalone, or when we only used standalone equipment, because nobody else was using the equipment at the same time that, that another person was using it, for example. So when the applications that initially ran on standalone computers started to be run on local area networks, some changes had to be made. So let's take a look at the requirements for shared usage, and we'll focus first on the hardware requirements for shared usage. Now, for hardware configuration, remember some of our options included memory, disk drive types, printer types, and monitor size and resolution. But one of the first things we would see then is the applications will improve with better hardware. Graphics are going to improve with more RAM on your graphics card, and with the bigger monitors that offer more resolution, the images and graphics are going to start to look a lot better. Now, another hardware configuration detail is the fact that a lot of these applications now require specific parameters to be set. Okay? And some people may not have all the parameters or all the characteristics that another user might have. So we have a couple of options in that case. The first one is we can use a default configuration for everyone. Okay? So what I'm saying here is that maybe not everyone has a CD-ROM drive, or maybe not everyone has the same color capability on their monitors. So the question then is, what do we do about this? And one of the things we can do is use this default configuration, which essentially means, here's my application, I'm going to set it to use only default hardware. Well, the problem with this is that if you go and spend lots of money on a high-quality monitor with lots of video RAM, then you suffer because you cannot take advantage of all of the state-of-the-art equipment that you just purchased. Okay, so that's one option, is just default configuration for everyone, and it's a waste of money. It wastes everybody's equipment. The next option is that we can actually store multiple versions of an application, each version configured for different hardware. Of course, whenever we store multiple versions of something, that's going to require more memory. And not only that, but probably a bigger headache is just managing the multiple versions when we upgrade to a newer version of the application. So this isn't a very useful method either for sharing shared usage. Finally, the most common and the easiest is to use something called a configuration file. And a configuration file contains personal information for each user. It contains each user's personal configuration. As I mentioned, this is the most common technique. It is the easiest to maintain. Usually what this is just one file that has all the information in it, and the application knows what that file is called, and it opens that file, reads in all the information, and then sets the parameters according to the information that it reads. For those of you on a Unix system, a lot of the times these are called RC files. or they're given a file name that starts with a period, so that when you do your regular ls command, these files don't show up when you issue that command. So if you want to see some configuration files, do an ls -al, where the A stands for all, and it'll show you all of your files. Especially if you're in your root directory, you'll see your .login file and your .cshrc file. These are all configuration files. Well, the preceding comments were all related to hardware aspects of applications and shared usage. What about software configuration? What do we have to deal with in software? Well, mainly in software, we need to set our personal preferences. And by personal preferences, I mean the colors that we like to see on our monitor, the sizes of the windows that pop up if we're using a Windows operating system, not only the size of the windows, but the number of windows that might pop up. And for software configurations, the solutions to shared usage are just very similar to hardware. And you could either use a default configuration, you could use multiple versions of the application, or you can use a configuration file just like you did for the hardware. Okay. How about some other shared usage problems? Let's talk briefly about contention. Contention is when multiple users try to access the same resource at the same time. For example, two users editing a document simultaneously, or in the case of a database, maybe two users trying to update the same database record at the same time. And we're going to talk about databases in the next chapter, but let's talk about some contention solutions. Okay, one solution is that we can schedule users to avoid contention. As an example, maybe you're working on a document and you say user A can only work on it in the morning and user B can only work on it in the afternoon. And that way you completely avoid contention because they are not trying to access the file at the same time. Well, this is a very poor solution and leads to a lot of waste of everybody's time. How about specifically to printers? Printers are common areas for contention problems to pop up. And what we commonly use is the spooler. The spooler resolves our contention problems, in fact, because the files that we want to print are captured on the disk. And then once they're captured on the disk, the jobs are scheduled for the printer, and that in itself avoids the contention problem. Now, one of the most common contention problems we have are for files. And so let's look at several different file open modes. We begin with exclusive open mode. Exclusive open mode simply says, go ahead and open this file if it's not already open. Okay, let me repeat that. Open this file only if it's not already open. So this is very restrictive, especially for people who only want to read the file. There's really no problem if a user is updating a file and somebody else wants to read the file. There's really not much of a problem to go ahead and let another user read it while it's being updated, because the other user cannot make updates. Well, in exclusive open mode, you can't even open the file for reading if somebody else has the file already open. So exclusive open is going to represent the most restrictive file open mode. The next one is protected mode, which says open for writing only if the file's not already open, but open for read only if the file is already open. Okay? So you see here we have two things we can do with the file. We can read it or we can write it. So in protected mode, if nobody else is writing to it, nobody else has the file open for writing, we can go ahead and open it for writing. But if it happens to be open for writing already, then we can go ahead and open it for read only. And then finally we have shared open mode, which happens to be the least restrictive file open mode. And this would allow multiple openings of a file simultaneously, basically without regard to whether it's open for reading or writing. We have two methods for shared open mode. The first one is shared update, where all the files can, anybody can open a file for updating at any particular time. So you might have 5 users opening the same file for updating. And you can imagine the chaos that might happen as a result of having a shared update open mode. The other type of open mode is called shared read-only, where as many users as you want can open the file and read it, but still only one person can actually update the file. Okay, so to summarize all of these different file open modes, let me go to my overhead. We have here our 4 different methods for file sharing. We have the exclusive, protected, the shared update, and the shared read-only. Okay, and the top part here says the file is currently opened as, and then it's one of those 4, and a request comes in to open the file according to one of these modes. Now notice that for exclusive, denied, 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 and across here, denied, 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 denied. So once again, exclusive open mode is the most restrictive of all of our open modes, and essentially means that if the current file is already open, we can't even open it for any other mode. Okay, we can't even do a read-only on that file. Now if the file is currently opened as protected, then can we open it as exclusive? No. Protected? No, because it's already open. We can't even do a shared open update because it's already opened in protected mode, and therefore only one person can update the file. But if somebody else wants to read the file, then that's okay. Now let's look at shared update. If a file is opened as shared update, then by default it can't be opened as exclusive, nor can it be opened as a protected mode file. But if somebody else wants to update it, then that's granted. And if somebody else wants to read it, then that is also granted. And then finally, if the file is currently opened as read-only, shared read-only, then we cannot open it as exclusive. We can, however, open it for protected, but only for reading. And then similarly, for the other shared modes, you can open the file for read-only as many times as you would like. Now let's talk briefly about database records. Databases are those software programs that store data in specific formats. We actually will be covering databases in the next chapter, so we won't spend a whole lot of time on this. But with respect to databases and file open modes, we can have multiple people open files, but each record in a database file might be locked. Okay? So once again, in a database, the files are allowed to open, but the records, the individual records, are locked. So what this does is it moves the data locking capability from a higher level down to a lower level, and it allows record level controls. So if one application wants to read a record, that record is locked and other read access or read requests are denied. Let me show you this with the help of a diagram. Here we have 2 applications, application 1 and application 2. Application 1 requires the data stored in record A. So application 1 would make a request, and if this is in the workstation, which it is because it's an application, the redirector is going to intercept that request, format the request, send it over to my file server, and the file server is going to take record A, send it over to application 1, but then it's going to lock record A. If application 2 also needs to read record A read record A request is sent by the application to the redirector, and that is sent over to the file server, but then the read request is blocked because record A is locked. Okay, so application 1 reads record A and locks it at the same time, and that disallows application 2 from accessing record A until application 1 unlocks it. Okay, well that locking of the various records can lead to a big problem. That problem is called deadlock, and above all, at all costs, you should try to avoid deadlock in database files. Deadlock occurs when two users are waiting on each other to release or unlock a record. And what can happen is that actually each user waits indefinitely for the other user to unlock the record. Let's see what I mean in this case. Now we have two applications, application 1 and application 2. Application 1, just like before, has read record A, and so record A is locked by application 1. Now we have application 2, which is a completely separate application, but it's using the same database. Application 2 has read record B, and so record B over in the database is locked by application 2. Now what happens? Application 1 makes a request to read record B. Simultaneous to that, application 2 makes a request to read record A. So both of these become pending requests because both of those records are actually locked. So unless application 1 releases record A or application 2 releases record B, then these two applications will be in what's called deadlock, and they can stay there indefinitely unless the database management system or the operating system realizes that deadlock has occurred and it can avoid or rectify that deadlock situation. Well, that brings us to the end of Chapter 5, and you know what that means. It means we have a true-false quiz for you to do. So if now's the time to turn off your videotape and do the true-false quiz. Hopefully you found the reading in Chapter 5 just reinforced my comments that I made on the videotape. And also hopefully you were able to answer these questions then on the true-false quiz for Chapter 5 without referring back too much to the text. So let's go through and answer these questions now. Number one function of LAN system software is I/O-oriented tasks like directing print jobs. That is true. In fact, printing is one of the most common tasks associated with local area network. Number 2, the purpose of system software is to insulate applications from hardware details. This is true. In fact, if it weren't for operating systems, computers would not be as popular as they are today because people would not have the patience to deal with the low-level details. Number 3, LAN system software resides only in a server. This is false. It resides in both servers and workstations. Number 4, the software module that collects printed output is called a redirector. This is false. It's called a spooler. The redirector was responsible for intercepting requests from applications and making a determination as to whether they were local or remote and then acting appropriately. Number 5, the ability of a software system to work on multiple requests at one time is called multi-threading. This is true. This is critical for a computer to have multitasking or multi-threading. Number 6, in a client-server application environment, the server can work on only one client's request at a time. This is false, and it is because of multitasking that servers are able to handle or work on multiple requests at the same time. Number 7, the 3 classes of LAN workstation software are application, workstation system, and client. No, that's false. Instead of the client, it's LAN system software. Number 8, when an application requests a service from the operating system, it does so by issuing a signal called an interrupt. That is true. And interrupts are also the reason why some applications don't work correctly when LAN operating systems are installed. Number 9, an application communicates with the network through an application program interface, or API. That one is true. Number 10, the LAN redirector sees interrupts only for remote LAN requests. That is false. The redirector receives all application requests. Only those destined for a remote device gets forwarded on to the local area network. The ones that are for local devices get forwarded right to the operating system. Number 11, the workstations connected to the LAN must all use the same version of workstation operating system software. This is false. In fact, that's one of the characteristics of a heterogeneous LAN, which is the most common, is that the workstations use different operating systems. Number 12, the medium interface portion of the LAN workstation software has two basic functions: placing data onto the network and receiving data from the network. And this is a true statement. Almost everything else occurs in the redirector or in the software on the LAN software on the server. Number 13, the LAN operating system approach taken by Novell with its NetWare is to integrate the server and operating system functions into one complete software package. This is true. The other option is to keep the two entities separate, and I listed some advantages and disadvantages for each one. Number 14, the LAN operating system approach taken by Microsoft with its LAN manager is to include modules that work with the Unix operating system. The false part of this statement is that it actually works with OS/2 and not Unix. Number 15, DOS is well suited for hosting a LAN because it is simple and runs on many computers. This is false. Although simple and runs on many computers is desirable, DOS is not a multitasking operating system. 16, one type of disk access optimization arranges the access requests in order so that read and write heads move methodically over the disk. This is true. And if you remember, my figures showed you how those disk accesses get lined up to improve the seek times for hard disk drive accesses. 17, some network operating systems increase reliability through a feature called disk seek enhancement. This is false. Disk seek enhancement was an optimized input-output function, not a reliability technique. Number 18, mirrored disks are used primarily to enhance server performance. This is false. They were used to improve reliability and fault tolerance. They didn't necessarily improve our performance, other than if you have the software to do parallel reads from each of the disks, then it might improve performance. Number 19, mirrored disks reliability can be extended using RAID. This is true. RAID was just basically a more advanced step of using multiple disks. Number 20, the best fault tolerance is provided by duplexed disks. This is false. The best fault tolerance is provided by duplex servers, which actually includes the whole duplication of the entire server, including mirrored disks. Number 21, a peer-to-peer network is one which has no dedicated servers. This is true. The server functions are managed by the individual workstations themselves. 22, one of the major strengths of Vines is a global naming strategy called Street Talk. That's true, I covered that. 23, IBM's LAN server operating system runs under IBM's mainframe MVS operating system. This is false because it runs under OS/2. Number 24, the LAN system software that collects printed output on disk is known as printer backup software. This is false. It is known as spooler software. 25, the software subsystem that allows several users to logically write to one printer at the same time is called a spooler. That is true. 26, backup software is responsible for keeping a server network operating system from failing. This is false. It helps restore the system after a failure, but it doesn't help prevent failures from occurring. 27, applications that are designed for LAN use typically or usually have a user-oriented configuration file that allows the application interface to be tailored to individual users. This was true. It had to do with the shared usage requirement. 28, one contention prevention mechanism, exclusive mode, is invoked when an application closes a file. This is false. It is invoked when an application opens a file. 29, shared open mode allows exactly 2 users to have the file open concurrently. This is false. It allows many people to open the file concurrently. Number 30, a user can open a file for write access if the file is already open in protected access mode. This is false. The file can only be open for reading if the file is currently open for write access in the protected access mode. Well, that brings us now to talking about other types of software that we're going to find on a local area network. Primarily, we've been talking about operating systems and software that controls the use of our peripheral devices that are attached to the LAN. So now what we're going to talk about is application software. And recall, application software is the software that actually does the work that we're using the computers for in the first place. The first one we're going to talk about is database management systems. Database management systems is a computer program that manages data by providing the services of centralized control, data independence, and complex physical structures. You could open your Newton's Telecom Dictionary to find that definition. Essentially, database management systems enable users to perform a variety of operations on data, including retrieving, storing, updating, and reports or documentation. So some LAN-specific characteristics of database management systems. There's always a high degree of import and export to other applications or database management systems. And by import or export, what I mean is you take a portion of that database management and you want to import it or merge it into an application or a word processing document, for example. The next characteristic is that they're highly shared among users. We talked briefly about some problems with contention when you're using databases, and talked about the issue of avoiding deadlock. And the biggest problem for database management systems is inconsistencies due to shared use. And I'm going to define inconsistencies for you in just a little bit. The next aspect of database management systems is the definition of a transaction. Transaction processing means updating a database record. Okay? Here's a definition of consistency in databases. A consistent state means all data is accurate and complete. Okay, so that's your definition. So in essence, a transaction then moves a database from one consistent state to another consistent state. In other words, it begins in a state with no errors and ends in a state with no errors after a record has been added, edited, or whatever you happen to be doing with the record. Now there's 2 ways to update records in a database management system, and both of them are used on a local area network. The first one is called batch processing. And batch processing collects pieces of data over time and then processes the data as a group. So in essence then, batch processing will essentially queue up the commands, and when it has enough commands, it'll send all those commands and execute all those commands one after another, but execute it as a group. The alternative way to process database records is called online processing. And in this case, we process events as they occur. Now, one of the key components of database management systems is that we must be able to return to a consistent state upon error. Now, we have a couple of methods for returning to a consistent state after an error. And the first one includes backing up the entire database before we actually begin our transaction. Okay, now you can imagine that databases can get to be huge files, And that would require a lot of time to back up a database before we begin a transaction. Not to mention the fact that we do hundreds and maybe thousands of transactions every day, and so it would require a lot of backing up. The other method for actually preventing inconsistencies is to not allow concurrent updates to take place. Okay, that's basically is going to prevent somebody else from modifying the record at the same time that another person is, because whoever stores their record first, that record's going to get overwritten by the person who stores the record last. So just by preventing concurrent transactions in the online processing mode, then that will help us prevent some inconsistencies. Let's look at an example of a database transaction, and we're going to look at a bank account. And the left side represents our savings account balance, and the right side our checking account balance. And before the transaction begins, our savings account has $5,000 and the checking account has $100. And our goal here is to transfer $2,500. Well, this has essentially two phases. After the completion of phase 1, the savings account has been, the balance has been updated to $2,500 because we have removed the $2,500 from the savings account. But that savings account has not, or the money subtracted from the savings account has not yet been added to the checking account. So right here, the data is inconsistent. Okay, if there was an error and somehow we could not complete this transaction, we would be leaving the database in an inconsistent state. Now, phase 2, for this example, actually does nothing with the $2,500 in the savings account, but it goes ahead and adds the $2,500 to the balance of the checking account. So now at this point, both of the account balances are correct and we're back to a consistent state. So again, at this point we have an inconsistent state, and if there was no way to rectify the situation, if we were unable to fix that, then we would have a customer that's out $2,500. Okay, what do we do with incomplete transactions? Essentially, incomplete transaction updates are reversed and not allowed. How are they reversed? Well, we can back up the individual records before we make any changes and then replace with the backup if the transaction is incomplete. Okay, this particular type or method is called transaction rollback. And let me show you how we do transaction rollbacks. Here we have the same bank account example. And in the first phase, remember, all we changed was the savings account. And so what we essentially do is before we modify the record in the savings account, we take something called a before image of the savings account. So the savings account before image is $5,000, and that happens to represent our initial state. Okay, so if the transaction was incomplete after this point, we would use the before image of the savings account to roll back that transaction to a more consistent state. We would essentially be rolling it back to the 5,000 and the 100. Now in the second phase, before we start the second phase, we take a before image of the checking account. Now the before image in the checking account had $100 in it. So if phase 2 does not complete correctly, then we can use the before image of the checking account to roll back the transaction and once again obtain a consistent state in our database. So finally then, after the completion of both phases, if they complete correctly, we have the correct amount of money that gets transferred from the savings account to the checking account. Okay, let's move on to other types of software. The next type we're going to talk about is called work group software. This is also commonly called groupware. And a work group is commonly defined as two or more users who share information they communicate in some way, or in some other ways just try to coordinate activities. The purpose of workgroup software is really to improve productivity. It is not intended to replace person-to-person interaction. Okay? It should make the group more productive. So let's look at some examples of workgroup software. The first one, and one that most people are probably familiar with, is email. And email collects and distributes correspondence electronically. Now, based on my experience in teaching this course, some people have never used email and therefore don't exactly know what it is. So I have a graphic here to help understand what email is all about. Email currently is a text-based application that allows you to type in messages, and those messages get addressed to a user and sent over the network to that user. So it's much like having a letter, which again is represented by text, shoving that letter or turning that letter into an electronic form and then transmitting that letter, for example, over your telephone. So you can have non-real-time conversations going on, so it's unlike the telephone in that regard, but nevertheless, there's certain steps involved with email. The first one is creating the message. To create the message, you can use almost any word processing software. Essentially, what you're trying to do is obtain a method for entering the characters into the letter, whatever letter you plan on sending over email. So then the next step for email is actually sending the letter, or the message, in fact, or instead of, it's not really a letter. It is a letter, but it's an electronic letter. And sending requires the network addresses of the recipients. And one particular aspect about email is the concept of an alias or a distribution list. And an alias or distribution list is it can be a file or just some method for associating a name with a bunch of addresses. So for example, you could have an alias or distribution list called Ames Community College, and that distribution list would include everybody's address that works for Ames Community College, or maybe all of the students at Ames Community College, something like that. So that's a very helpful aspect of email software, because then you don't have to type in literally everybody's address that you want to send the message to. And one final aspect of sending is the use of the domain name server for interpreting addresses. Recall that, for example, if you want to send something to somebody that works at Ames Community College, you would have their user ID, then the @ symbol, and then it would say, for example, ames.edu. And it's the domain name server that takes that ames.edu and associates with that an IP address, and therefore the network has some specific numbers associated with it and can figure out how to route that message to the recipient. The next aspect about email is reading the message. And reading the message, there's several ways you know that you have a message, in fact. When you first log in, sometimes you get a message that says you have new email or new mail, and that'll display on your monitor. Another method is occasionally you'll have an icon associated with the application, and I can only speak for the one I use. Mine is a little mailbox, and whenever I have mail, my little mail flag pops up on my mailbox. And then I also get a beep to get my attention if I don't happen to be looking at the monitor. So those two items help you realize that you actually have an email, a new email that has arrived. At that point, you have several options. You can ignore the email. You don't have to look at it at all. You can look at it later. You can read the mail and delete it. You can read and store it to a file for future reference. You can read and forward the email to somebody else that was not on the distribution list. And finally, you can read and reply. All right, so you can read an email message and then just usually click a button or enter a command to automatically reply. and that command will also append the address of the destination, which happens to be the address of the originator of the message. Okay, some other aspects about email that I just want to briefly mention. You can have expiration dates on your email messages. Some applications offer this. With an expiration date, the message is deleted after a certain period of time. You can have a certified mail service, which means when you send an email to somebody, when that email is received and actually read, the email system at the destination will actually send you back a confirmation to certify that it was read. Doesn't necessarily certify that it was read by the right person, but nevertheless it certifies that it was opened and read. There's another concept called a mail agent associated with email. And a mail agent is a software module that can automatically act on behalf of a user. And the most common example of this is for forwarding, email forwarding. If your address changes or you move locations, you can install an agent that will forward any messages that come to you, forward them to your new email address. Another helpful aspect of email is called message attachment. So you can attach enclosures to your email messages. And some enclosures that you might want to attach are, at least the most common, are images and maybe scanned documents or something like that. So you can attach those to your email message. And finally, we have a standard here, the CCITT-X.400 is considered a mail interchange system. And where this comes into play is the fact that many applications use slightly different message formats to send their email, and unless there was a standard way to interpret these formats, it would make it difficult to communicate. So X.400 is a commonly used standard. It's used to basically change the formats of emails so that most of the email application programs can actually interpret your email messages and would allow you to read them then. All right, and coming soon to an email near you is the ability to attach voice messages. So instead of opening and reading a message, you'll be able to click on it and hear a voice message. And then also the idea of encryption, which would not allow people other than yourself or whoever had the key to actually decrypt the message and read whatever it is that was just sent to you. Okay, let's move along then to another work group application, and that would be called electronic conferencing. With electronic conferencing, there's several aspects to this that are beneficial. It allows scheduling of meetings. It allows meeting reminders. It can actually remind you of certain meetings that are about to occur, for example. It can resolve conflicts between attendees of a meeting. It can make meeting proposals. So if you want to propose a project group meeting, it can send out a message to all of the intended attendees of the meeting to say, for example, I'd like to request a meeting at 10 a.m. on Friday, and all this message goes to all users, and then the users can actually respond with, sorry, that doesn't work out, or okay, I have it on my system, or something like that. What I have found is that electronic calendaring only works if everybody in the group has electronic calendaring. I was just involved in a project where I happened to work on a Unix machine, and some people on Macintoshes were using Meeting Maker, and I kept getting left out of meetings because somebody would propose and schedule a meeting on Meeting Maker, and nobody would tell me about it, so I would know nothing about a meeting, find out after the fact that a meeting existed, and evidently it didn't concern me too much because the meetings that concerned me, they managed to make sure that I was there. So maybe that was a good thing. I don't know. The next work group application is called electronic conferencing. This is like video conferencing, but you get to stay at your desk. There's usually a little camera that's mounted on top of your computer. And that takes a picture of you, and a lot of times these are in real time, or they might have a reduced frame rate. The other application for electronic conferencing is the sharing of images and diagrams. And the important aspect of this is the ability to modify your image in real time, so that whatever modifications you make on your computer, those modifications show up at the destination computer in real time, basically as you make those modifications. The next workstation application software is workflow automation. Workflow automation is used to monitor the progress of projects and such tasks that you might want to have when you monitor the progress of a project is delegation of tasks. Usually projects encompass many small subtasks, and so you can delegate to individuals who is responsible for certain tasks. You can delete tasks, and if everybody has workflow automation, then everybody will know that that task was deleted and in fact completed. And a big plus on workflow automation is the ability to gather data and generate reports. Okay, let's move on. Document co-authoring and management is a really big workstation application. This is where two or more people can work on documents concurrently. So at the same time, two people can be working on the same document. What this does for you is it improves organization, it improves archiving, locating, and full file searching. So those are all key components of document co-authoring and management. Group decision support software. This is an interesting one. It facilitates the sharing of ideas among group members. And what's interesting about this is that the users of this software can maintain some anonymity. I think the purpose of this, or it was designed by somebody who kept getting stepped on in meetings, because some people tend to dominate meetings, and maybe they don't have the proper etiquette, or for one reason or another, tend to, I don't know, humiliate people or something like that. With anonymity being maintained, people can submit their ideas, and nobody really knows who submitted the idea, and therefore people don't know who to step on. I guess that was the idea of group decision support software. Then we have more of primary business software. This is probably what you'll find more on mainframes and mini computers. But the purpose of primary business software is personnel management, payroll, accounts receivable, and accounts payable, and ledgers, inventory, financial, and manufacturing goals. All right, internal software standards. What this refers to is the choosing of specific vendors for your word processing applications and your database management systems, your spreadsheets, whatever applications most people are going to find useful on the network, maintaining consistency between across the versions for all the maintaining consistent vendors for all of the programs. The benefit of this is that it improves portability. In other words, I can speak from experience here. There's a couple of word processing software packages that are used at US West Advanced Technologies. There's Microsoft Word, there is FrameMaker, and LaTeX is also used frequently. And if you happen to be on a Macintosh where you're using Microsoft Word and you're co-authoring a document with somebody on a Unix machine, then typically what happens is you have to take your document and store it as something called an RTF file, or I think a rich text format, something like that. And then the other programs, that's pretty much a standard file format that a lot of the word processing programs can read in. Unfortunately, when you make that conversion, you lose a lot of the formatting aspects of the word processing documents, so it's not real handy. If everybody has the same vendor, then you could take a document, just give it to somebody else, and that person could edit it without doing any file converting. So that's a benefit of having internal software standards. The other benefit is that it simplifies training and reduces training costs, because now you can have one person doing the training, holding big classes, learning how to use Microsoft Word or FrameMaker, for example, instead of having several different classes and having several different instructors. The result of this is improved productivity due to fewer conversions. Okay, by conversion, again, I mean changing from a Microsoft Word to an RTF file, which FrameMaker can then read, so you don't have to go through all that baloney. And there are some important considerations for software applications. One is the ability to run on several different platforms. Ideally, you'd like to have a low average cost per user. The most flexible applications allow the ability to import to and from other applications. So importing database information into your word processing application, something like that. Ideally, you want it to be robust and free of bugs. This is true for any software you buy for a computer. You want that software to include documentation. And again, ideally, you'd like to have free or low-cost upgrades. And finally, actually not finally, but you'd like to have it compatible with a variety of local area networks. And now finally, you'd like it to have reasonable hardware requirements. By this last one, I mean you don't want to have to go out and buy more video RAM in order to run the application and get the most use out of it. Moving on to software protection, this has to do with how the vendors protect themselves from software piracy, but also copyright protection and licensing also provides you some benefits. Software usually comes with a license agreement, and it's the license agreement that outlines the rules of use for the software package. One of those rules of use usually is the statement to the effect that you're not allowed to copy this or distribute it to somebody else, which is called piracy. There's a couple of methods for preventing software piracy. One is you can keep the code secret. This is basically down when you're developing or manufacturing the software. You want to keep the source code secret so that that'll prevent competitors from using your proprietary algorithms. Another method is to have it copyrighted, which means that it would be illegal for anybody to copy the software, and if somebody did copy it, then they could be prosecuted under the law. Copyright is essentially legislation to deter copies from being made, but I guess my point here is that without law, you need to have enforcement in order to make a law take effect. So if nobody's out there enforcing copyright laws, then what good is the law in the first place? Next, we have copy protected. There are methods that you can put on disks that will allow your that will prevent your copy programs from copying any of the data or programs on the disk. It was kind of interesting many years ago. Software vendors were putting these sorts of things on their disks to prevent copies, and at the same time people were trying to come up with ways to break the copy protection software. So you had this constant competition that was people were doing it basically, or they would claim they were doing it just for the challenge of it. They wouldn't actually copy programs. So that's probably how they got around the law. Finally, the final method for preventing software piracy is special hardware. For example, keys on parallel ports. This is actually an interesting concept because what literally is included with the software package is a little piece of hardware, it's called a key, that is for example, a 15 or a 25 pin connector that you connect onto your parallel port, for example. And then the printer cable, which normally would attach directly to parallel port, is attached to the other end of this key. So whenever you execute a software program, the first thing it does is go to the parallel port and check whether or not the software key is on the parallel port. And if it is on the parallel port, it continues with its execution. If it is not on the parallel port, it prevents execution. So that's an interesting concept, special hardware. And another one I'll just mention is disk keys. My son recently had a computer game that after about 2 weeks of playing it, the software automatically asked him to insert the original disk. And only after we inserted the original disk did the application actually fire off then. So if we would have pirated that software from somebody else, we would not have had the original disk and therefore would not have had the ability to run the application after just a couple of weeks. Let's talk a little bit about license agreements now. Several types of license agreements. There's a single user per workstation agreement, which is probably the most common type of agreement. What this means is that only one person, the software can be installed on one workstation, and only one user can use it at a time. Then there's a single user multiple workstation. The idea of this is that if I purchase the software for me to use, I ought to be able to use it on any particular any particular computer I happen to be working on. Then there's the restriction on the number of concurrent users. This is more oriented towards local area networks, where you have one version of the program stored on a file server, and you can only have a certain number of people executing that application at the same time. To get around a restriction on number of concurrent users, there's a server license you can obtain, which allows you to execute that program on as many nodes that have access to that server. Then there's a site license, which is a lot more general, pertains to basically a building or a site for a company, and anywhere on that site you can run the application. And then finally there's a corporate license. So US West, for example, could go out and purchase a corporate license so that they could use that application anywhere within the US West facilities. Now, what does software protection give the owners? So let's talk about owners' rights. It allows the owners to transfer the license to another user. So if I buy a software package and I use it for a while and I don't like it anymore, I don't use it, I can give that away to somebody else. I better make sure that I delete it from my hard drive though, or else I'll be violating the copy protection policy. Interestingly enough, owner's rights are supposed to give you a refund if it's defective or does not work as stated. You might have a little trouble proving this to the store that you bought the application from. It excludes you from liability for losses or damage. And finally, you can terminate the license at any time by just simply destroying it and destroying the disks and removing the software from your hard drive. That brings us to the end of Chapter 6. Chapter 6 is a relatively short chapter. One thing I want to do before we move on to the true-false quiz is to look at problem number 4 on page 169. So if you'll do me the favor and take your book out. Problem 4 says, your company is considering purchasing a software product that provides a layered pricing scheme for licensing. A 5-user person costs $1,000 and includes 2 copies of documentation. Additional user licenses may be added in increments of 5 users for $500. The incremental licenses do not include documentation. Additional documentation sets can be purchased for $35. Your company has 75 workstations, but has been determined that the maximum number of concurrent users for this software package is 53. What is the total cost of the software and documentation if 40 additional sets of documentation are required? Okay, well, the company needs the basic 5-user package, which is going to be $1,000, and then it's going to need 10 of the 5-user upgrades, and each of those 5-user upgrades costs $500. Now notice here that the additional licenses for 5 users initially was 1,000, but subsequent 5-user licenses are only 500. That's one of the advantages that I pointed out for having a local area network, where the additional licenses to run software is usually less expensive than buying individual sets of the software. So for the software licenses, we end up with $1,000 for the initial, and then the 10 extra packages at $500 each, or $6,000. Now, documentation is always important, especially if you are going to have 53 other users that could be using the software package. So to finish out this problem then, we wanted additional 40 sets of documentation, and each set is going to cost $35, and that's a total of $1,400, which has to be added then to the $6,000 for the software licenses. And you can see how the total cost for software and documentation then is $7,400. So the point here is that the extra licenses actually cost you less than the initial 5 licenses. Now that brings us to Chapter 6, True-False Quiz. So please go ahead and turn off the video and do the True-False quiz. Hopefully, once again, the reading of Chapter 6 supported the comments I made in Chapter 6 and allowed you to hear the material for a second time and cruise through this particular true-false quiz. So let's see what sort of answers you might have gotten. Number 1, database files tend to be highly shared and are more apt to lead to contention problems than word processing, spreadsheet, and similar application systems. The answer to this would be true. Database management systems are highly shared on a local area network. Number 2, a transaction is a database activity that moves the database from one consistent state to another consistent state. That is true. Number 3, being able to define transactions in a database management system provide database security. This would be false. Okay, has nothing to do with security. Number 4, before and after images are another method of taking data backups. This is false. Data backups usually refer to backing up the entire file, and in this case, the before and after image simply represents what happened before the record, making sure the transaction completed to a consistent state, and then getting rid of that before image. Number 5, applying before images to return to the database or to return the database to a consistent point is called transaction rollback. This is true. Number 6, an email system has many of the capabilities of a conventional postal system. This is correct. We address the email. We can have mail agents to do forwarding for us. We can have certified mail, those sorts of things. Number 7, like a conventional postal system, an email system typically provides a stamp function to charge users for sending a message. This is false right now, but I wouldn't be at all surprised if in the future we started to see something like that. Of course, it might mean the demise of email as we know it. So, number 8, some email systems allow users to use separate word processor software to create a mail message. This is true. Really, any mechanism to enter a text message is useful for email. Number 9, a distribution list is a directory of all mail users. This is false. It's a list of recipients of a certain group. Okay, for example, the Ames Community College group would contain all of the addresses of the Ames Community College faculty or students. Number 10, with certified mail, the mail message is automatically filed in the recipient's mail folder. This is false. The certified mail sends an acknowledgement to the original sender when that email message was actually read. Number 11, a mail agent is a software module that can automatically act on behalf of the user. That's true. That was the definition of our mail agent. 12, the CCITT X.400 mail standard describes capabilities like broadcast and mail classes that a mail system should implement. This is false. It defines a common standard for email messages. 13, electronic conferencing groupware helps in arranging a meeting or conference. This would be true. 14, electronic groupware calendars can automatically schedule meetings at a time most convenient for those scheduled to attend the meeting. This is also true. It's one of the advantages of electronic calendaring is just to be able to find out when is most convenient. Number 15, the critical path of a project is the sequence of events that takes the shortest time to complete. I didn't talk much about project management in this module because this isn't a project management course. The author, however, does talk a little bit about it. The answer to this is false. The critical path is that path which takes the longest time to complete. 16, with workflow automation groupware, a manager can assign tasks to individuals or groups. That was true. 17, a full function document co-authoring system allows 2 or more workers to access a document concurrently, but allows only one of the users to update the document. This is false. In that type of a system, all of the users can update the document concurrently. 18, an important aspect of groupware is the replacement of person-to-person interactions. While not intended to do this, sometimes that's what it does accomplish. The answer, however, is false. It's not intended to replace person-to-person interactions. 19, a primary reason for downsizing is the availability of spoolers on LANs. This would be false. We had some other reasons for downsizing. You can revisit your notes from Module 1 where it talked about downsizing. Number 20, most application and system software usage is governed by a license agreement. That is true. The license agreement protects both the manufacturer of the software and it also gives the owner certain rights. 21, license agreements are intended to protect the rights of only the software manufacturer. This is false. I just answered that. It gives the owners of the software rights also. 22, a few software companies protect their software by requiring the use of a special hardware device that attaches to a serial or parallel port. This is true. That special hardware device is commonly called a key. 23, a key disk is usually a flexible disk that must be in a disk drive when the application is run. This is true. That's basically the disk that I was talking about earlier when we tried to run the application for the computer game and it asked us to put in the original disk. That in essence was functioning as a key disk and providing some copy protection to the manufacturer. 24, when you buy a software product, you get unrestricted use of that product. Well, that's false. We had several types of licensing agreements. We had single user, single workstation, single user, multiple workstation. What were some of the other ones? We had concurrent user restrictions, server licenses, site licenses, corporate licenses. So you have to buy one of those types of licenses in order to gain the ability to use the application by more than one person. Number 25, a common licensing agreement for LAN software is a restriction on the number of concurrent users. This is true, and the reason is because software that you buy for a LAN usually resides on the file server, and only one copy resides on the file server. So anybody attached to the LAN theoretically can make a request to run that software, and it gets downloaded to your workstation. What normally happens, however, is that on the server there's a program that keeps track of how many requests have been made and how many applications are currently in use. And if the threshold is exceeded, it does not allow the application to be downloaded to your workstation. So that's how the concurrent user's license would operate. Finally, number 26, a server license allows the software to be installed on one server and gives all users attached to that server the right to use the application. This is true. With a server license, there's not a concurrent user or concurrent number of users restriction. Okay, as long as it's on the server and you have access to the server, you can run that application if the application came with a server license. That finishes up chapter number 6, and it also finishes up module number 3. And since there are 6 modules in this course, we've come to approximately the halfway point in this course. I mentioned in the course outline that after or sometime during the course we would do a practice midterm. The practice midterm is intended to do several things for you. One is it's going to act as a review. Do you understand or remember all of the material that we've covered so far in modules 1 through 3? So the midterm actually contains questions from each of the chapters covered in modules 1, 2, and 3, which incidentally, those chapters, module 1 covered chapters 1 and 2, module 2 covered chapters 3 and 4, and module 3 covered chapters 5 and 6. So you can see that we're not quite halfway through our local area networks book. The second function of the practice midterm is to give you an idea about what to expect on the final exam. On the final exam, you're going to have 1 hour to take a multiple choice test. The midterm is also multiple choice. I've designed it so that it should take you approximately 2 hours to complete the final or the practice midterm. So my advice is to set aside about 2 hours worth of time and set a timer for 2 hours, or start your stopwatch, and then do the exam just as though you were doing it on as the final, and keep track then of how often you have to go back to the textbook in order to find the answer to the question. Because what that's going to help you do then is when it comes time for the final, you'll know how much studying you have to do before you take the final. The final is open book, so you'll be able to go through the book to find the answers, but keep in mind that you'll only have an hour, and if you have to look through the book too many times and for too long a period, your hour is going to be up and you won't be able to finish the exam. So what I'd like you to do now is turn off the videotape and recognize that this ends module number 3 and that we're going to do a practice midterm exam. You were given 2 hours to do the practice midterm, and hopefully I calculated correctly, and it would take you approximately 2 hours. So for those of you who took the exam and it took less than 2 hours or 2 hours or less, go ahead and just raise your hand. Great, great, thanks. Well, let's go ahead and review the answers then to our midterm exam. Number 1, the first microcomputer was, the answer is number 3, the Altair 8800. It actually predated Apple by about 2 years, and I believe predated IBM by, I think it was 5 years, something like that. The Radio Shack must have predated that Radio Shack computer by, I don't know, 25 years. No, that's just not true. So, question number 2. Which of the following is not a physical security measure? Now, you're going to note, or you probably already have noticed, that I use a lot of nots and trying to get you to think through which of the 4 answers are, and then which ones of the 4 answers are, for example, in this case, physical security, and that will point out to you which one is not physical security then. So the answer to number 2 is number 1, passwords. Recall that physical security were basically physical things that would keep people away from accessing your data, like locks on doors, locks on the computer. I showed you the little key lock on the PC we were working with. security guards, physical security. Number 3, which of the following is not a logical security measure? The answer is door locks, because that's a physical security measure. Number 4, which of the following is not true of encryption? Anyone who knows the encryption key can decipher the message. That's true of encryption. Encryption scrambles the data so unauthorized users cannot make sense of it. That's true of encryption. If an unauthorized user loses the encryption key, he or she is unable to easily decipher the data. That is true of encryption. So we can skip down right now and say all of the above are true statements about encryption. Because if we have more than one, and we don't have something that just says numbers 2 and 3 or whatever. Number 5, contention will occur when 2 or more users attempt to share the same resource. So that was basically the definition given in both the text and in my notes. Number 6, which of the following is not an advantage of or reason for using a LAN? Ease of management was a reason for using a LAN. Cost effectiveness, downsizing, and management control were all reasons for using a LAN. So the answer then is all of the above are advantages of or reasons for using a LAN. Number 7, as defined in the text, portability means the ability to transfer an application or data from one system to another. So the answer would be choice 3. Number 8, which of the following is not a LAN characteristic? Covers a wide geographical area. Is that a LAN characteristic? No. So the answer there is choice number 1. You can do it by the process of elimination. Say resource sharing is a characteristic of LANs. High speed is a characteristic as well as transparent use. Number 9, which of the following media is least commonly used on a local area network? The answer is satellites, and the reason is because satellites have a long delay due to transmission that would interfere with the protocols used in networking. In fact, there was an article in the Denver Post the other day about the TCP/IP protocol not working with satellite networks, with satellites as your medium. And this was a big shock to everybody involved with the launching of satellites. It came as a big surprise. Number 10, which of the following is not one of the 4 essential elements of communication? We had 4 elements. We had sender, receiver, message, and understanding, or the medium. And so the answer there is choice number 1. The computer was not one of the essential 4 elements. Number 11, although not one of the 4 essential elements of communication, which of the following was cited as an important part of communication? The answer is error detection. That's an important part of communication. Number 12, in a terminal network, a host computer is usually a mainframe computer. The host computer does all or most of the processing and has dumb terminals attached. So the answer is all of the above. The acronym WAN stands for Wide Area Network. Which OSI layer is responsible for routing and collection of accounting information? The answer is the network layer. Number 15, which OSI layer is responsible for delineation of data and low-level error detection? Delineation of data was one of the responsibilities of our data link protocol. So the data link layer is the answer, choice number 1. Number 16, which OSI layer is responsible for establishing dialogue rules and message flow control? The answer is choice 3, the session layer. Number 17, which OSI layer is responsible for end-to-end message accountability? That would be the transport layer, choice number 3. Which OSI layer is responsible for signal representation on the medium? The physical layer is always responsible for what happens on the medium, so the answer to number 18 is choice number 1. Number 19, the network topology describes, choice 3, the model used to lay out the medium and node connections. It's definitely not number 1, how a workstation gains access to the medium, because that is the Media Access Control Protocol. Number 20, the Media Access Control Protocol describes the way in which a node gains access to the medium. That is true. Is part of the OSI data link layer. That is true. Maybe token passing. That is true. And so the answer is all of the above. It's important when you're doing multiple choice questions, multiple choice tests anyway, to determine whether one of the questions or one of the answers is all of the above. Because a lot of times you'll see an answer that you know is correct, so you choose that one, when in fact the answer is all of the above. So make sure you take that into consideration when you're doing the final exam. 21, which of the following is not a common LAN topology? Well, the 3 common topologies were ring, bus, and star. So that leaves hierarchical as not being a LAN common topology. Number 26, the LAN medium capable of the highest speed is fiber optic cable, choice number 2. 27, adding or moving a workstation is easiest with which of the following LAN media? The answer is wireless media, because you don't have to rewire cable to wherever you're going to move the workstation to. 28, which of the following media is most immune to electromagnetic interference? The answer again is fiber optic cable, and the reason is because the method used in fiber optic cable is to transmit light pulses, which are immune to the electromagnetic interference. 29, frequency division multiplexing is used in broadband systems, so choice number 2. The bandwidth of a medium is directly related to the medium speed. That is true. The range of frequencies the medium can carry. That is true. And it is measured in hertz. So they are all true. Therefore, all of the above is the correct answer. The IEEE 802.3 standard describes, let's see, CSMACD is 802.3. So the answer is choice number 3. Haven't come up with a nice rhyme yet for 802.4, but that describes a token passing bus. Number 33, 802.5 keeps token passing alive. So, token passing ring alive. So the answer is choice 2. 34, with basic token passing, only the node holding the token can transmit a message. Has nothing to do with requiring a token in order to receive a message. It's only on the transmit side. With token passing, collisions cannot occur because, first of all, if you have a token and you can only transmit when you have the token, then only one workstation should be transmitting at one time. 35, in token passing, the token may be lost. When this occurs, one node is responsible for regenerating the token. The one node is called the active monitor, and he essentially, as soon as he gets rid of the token, he starts a clock, and if he doesn't get the token back in a certain period of time, then he assumes the token has been lost. Because again, in a token ring configuration, or even in a token passing, you can theoretically calculate a maximum value, a maximum amount of time that it takes for that token to circle all the way around. 36, terminators are used on some LANs to eliminate signal feedback at the medium endpoints. It's definitely not to echo back any signal, because then that would essentially be like putting another signal onto the network. 36, a cyclic redundancy check, which is also usually abbreviated CRC, is an error detection scheme. So it's choice number 4. Transparency in a data link protocol means control characters can be transmitted as data. Recall the problem with transparency, or transmitting binary data rather, is that some of your binary data characters might look like control characters. So transparency in a protocol means that the characters that represent control characters can show up as data, and that would not interfere with your protocol. 39, in pure contention media access, which means CSMA-CD, each network node has equal access to the network. Okay? It doesn't have anything to do with the token. There's no priority schemes, so it can't be number 3. And there's no supervisor that directs traffic on contention protocol. So the answer again is choice number 1. In CSMA-CD, if a collision occurs, the stations wait a random interval and try to retransmit. So choice number 4 is the answer. The type of server that allows 2 or more users to share an application program is called a file server. Remember, a disk server partitioned disks into physical sections that were not accessible by anybody but the user it was assigned to. Database servers were strictly used for database files and making calculations on databases. Print servers had to do with handling print jobs and scheduling print jobs, so that leaves the file server. 42, the type of server that will be involved with a spooler is a print server. A spooler is what allows logical printing on a local area network. So that has to do with the print server. The type of server that receives a request, processes it locally, and sends the results back to the user is a database server. The database server is the one that contains database files. You use structured query language, or SQL, to make your commands that you want to give to your database server. The database server then accesses the records directly, doesn't send the records over the network, accesses the records, makes the computations, sends only the result back to the user. Number 44, the server technology that might reduce the number of characters transmitted over the medium is a database server again, because again we don't have to transmit the whole file over the network. We just simply transmit some commands to the server and it only transmits the results back. Which of the following is not a component of disk access time? Well, there were 3 components to disk access time. There was seek time, latency, and then the data transfer. Just to review those, the seek time was the time to move the head over the right cylinder. Latency was the time for the data to rotate underneath the head. And then data transfer was the time required to transfer the data. So disk cache is not a component of disk access time. Which of the following represents the average time for data to rotate under the read-write head of a disk? The answer to that was latency. 47, which of the following represents the average time for the read-write heads to move to the proper cylinder of a disk? That, out of those 3, was called the seek time. 48, a disk cache attempts to reduce the number of physical disk accesses. Remember, we had something called a logical read and a physical read. Physical read was where the operating system had to actually go to the disk to make the read. Logical read means it found the data that it was looking for in the disk cache, which sometimes can be 100 times faster than a physical read. So disk cache reduces the number of physical disk accesses. 49, the most common LAN backup device in use today is the magnetic tape. 50, the main disadvantage of diskettes as a backup medium is the storage capacity per diskette. Remember, for a 1 gigabyte hard drive, it'd take about 700 1 1/4 or 3.5 inch stiffy disks to back up that disk. 51, you may need to add more memory to a microcomputer when connecting it to a LAN because LAN applications require more memory. That is true. The required disk cache will take up more memory. Under ideal situations, you'd like to have a larger disk cache. And the workstation network software must be resident in the workstation. That is true also. The network software actually is a TSR, a terminal stay resident. So the answer is all of the above. A LAN adapter provides the connection between the medium and the computer's bus. So choice number 1 is the answer to 52. A printer driver is a software module that determines how to format data for a specific printer. So choice number 4. Number 54, a transceiver helps make the connection of a computer to the network. That's true. May be connected directly to the medium. That's true. May be located on the LAN adapter. That's true. And it helps send and receive network data. So the answer to number 54 is all of the above, choice 5. 55, a multi-station access unit, that's what MAU stands for, helps establish the ring topology in a token ring network. So the answer is number 4. Recall that we had a star-wired topology, and essentially a MAU looks like a star because all of the computers are wired directly into a central unit, if you will. But internal to that unit, a ring is actually formed. So that's what the MAU does. LAN system software runs in a server. That is true. Runs in a workstation. That's true. Insulates applications from LAN hardware details and redirects network requests from a workstation to a server. That is true. So the answer is all of the above. One thing I'm starting to notice here in the development of my test is everywhere I have a question that says all of the above is one of the answers, that turns out to be the right answer. Just to let you know, that will not be the case on the final exam. Number 57, the function of the redirector software is to channel network requests from a workstation to a server. So that's the primary function of the redirector. 58, a workstation application issues a request to write to a server disk. The system software module that will handle this request is generically called a redirector. 59, the ability of a software module to work on multiple requests at once is known as multi-threading. Also known as multitasking. 60, an interrupt requests intervention from the operating system. That's what an application does when it needs assistance from the operating system. It issues an interrupt. Can signal an I/O completion. Can be generated by hardware and can be generated by software. So the answer to this is all of the above. Which of the following is not a LAN operating system function? I/O optimization is the function, memory management is, fault tolerance is, and disk caching is. So that leaves database management as not an operating system function. 62, disk seek enhancement orders the pending disk requests. Okay, that's exactly what it does. It orders the request so that the head of the disk moves methodically over the cylinders on the disk. 63, with disk mirroring, data must be written to both mirrored disks. Okay, so choice number 3. Data are read from both disks, that's number 2. I pointed this out as being a benefit where you don't read the same data from each disk. You can make 2 requests, independent requests to each of the disks, and you can do reads in parallel. So 64, which of the following is not a likely spooler option? Well, hold jobs in the disk queue after printing, that was an option. Delete a job from the print queue, that was an option. Allow a user to view jobs in the print queue, that was an option. Deadlock detection had to do with database management systems and preventing users from waiting on locked records. So the answer to 64 is choice 1. 65, which of the following open modes provide the highest level of file sharing? Highest level of file sharing is obtained with the shared open mode. If you said exclusive, you're just at the wrong end of the spectrum there. Exclusive provides the lowest level of file sharing. So once again, if this test took you longer than 2 hours to do, then you probably need to study a little more for the final than you did for this midterm. What that's going to allow you to do is answer the questions more rapidly and allow you to finish the exam within the 60-minute time period that will be allotted to you. So that finishes up the first half of LAN WAN concepts.